Right, so lesson 2 we're going to be looking at base mapping. And these are the layers that you're going to use to draw over the top of. This might be an ordnance survey map, it may be the results of a topographic survey, it might just be any map that your client sends you that you want to include in your product, in your project and in your map, either to help you create data or as your final base map on the actual map that you're going to produce. You can get some data online for free. You can also go to websites that provide mapping services that actually sell base maps as well. Or like I said, these might be maps that your clients just sent you over that they've either produced or purchased themselves. So the first thing we're going to do is go and have a look at one of the websites that actually sells base mapping data, and this is eMapSite. This is one that I use. Never really used any others. This is just the one that was showed to me a long time ago. Other ones are available, but I've just basically stuck to what I've known. Generally, prices are pretty much the same, and the types of data you can get from them are pretty much the same as well. There are some specialist ones for things like LiDAR data, but let's just take a look at this here. So your mapping data may be something like a aerial photograph. We've got all these other different products in here. Some of them are going to be completely pointless, and because they are at too high of a kind of too low resolution to be useful, like the traditional kind of OS Land Ranger map is. I mean, you could extract a site boundary from that, but and the location of some buildings and some ponds here, but it's not really too much use. OS Explorer map, again, bit more detail. You've got some paths and some other areas mapped out in here. The map district, that shows you things in a slightly different way. This has got mapped out the kind of areas of buildings, woodland and roads and some water features. Open map, local raster. This is one of the mapping products that's actually available for free through Ordnance Survey, and is possibly quite useful for large sites. Smaller sites, maybe not so much, but definitely on large sites. This is the product that I generally purchase the most. OS Vector Map Data gives you a lot more detail on there. Generally quite useful for base mapping to overlay your map on top, and also gives you some boundaries that are also useful for when you're creating your map. The absolute kind of gold standard is Ordnance Survey Master Map, and it's also the most expensive. This isn't it, it's auto zooming, so when I zoom in further you'll see that is the most detailed. You've got kind of boundaries of vegetation types here. You've got the kind of the corners of buildings nicely, quite detailed. It's basically the best possible one that you can use, but it's also the most expensive. So we'll take a look at some of the prices for these kind of products. First of all, we'll look at, see, this is the master map data. For that area, you're paying nearly £300, which for a site of this size, you're probably doing the phase 1 survey for cheaper than that. If we look at aerial imagery, it's actually quite reasonable, the prices for aerial photographs. So for a 12.5 centimeter resolution, so basically anything that measures 12.5 centimeters on the ground, you would be able to see that on your aerial photo. Just 33 or £34. If you don't need it that detailed, it gets cheaper, down to a meter resolution, £12.50, 5 meter resolution, £10. But if you wanted their most accurate version, 5282, which again for some sites may not be too much money, depending on your client really, if they're willing to pay for it. Obviously the bigger area that you're using, the more expensive it's going to be. If we look at the vector map raster, I believe that's in popular products. Vector map raster 1493, and that'll give you something that for the majority of sites is actually fairly usable. So I was talking about the open map data as well. That's available through OS Open Data. They provide all different scales. You can either select an individual grid reference square, or you can select the whole country, and you download that. They send you an email and then you just download it from the link. It's free. You do have to give them some details just because they monitor who's using the data. Should also mention that it's available in vector and raster, and we'll take a quick look at that and what exactly that means in a second. So if we go and have a look at some of that data, we'll just open that project that we've created earlier, and that so this is data that I've downloaded previously from eMapSite. It comes in two files. One is the actual image, and the other is a file that shows you exactly where that image is going to be positioned within your map. So that's pre-georeferenced. All you do with that is basically drag and drop it in. I'm not going to do that because you'll be able to see then where this site is, and this is from one of my actual active projects at the moment. That's not in the public domain, so I'm not gonna actually bring that into the project. But we'll have a look at the data here. So raster data is image data. If we just open that image, just in a normal image viewer, we can see that it's just an image file. It's a bitmap image. The more you zoom, the more blocky it gets. So the individual mapping unit of a raster map is an individual pixel, where a vector map, it's actually files, GIS files, shape files, and in those it contains all the instructions it needs to actually draw those shapes. So I'll bring both sets of data in. So all we need to drag and drop in here is the .shp files. Can be quite confusing because the group of files associated with any one layer is a shapefile, but there's also a .shp file as well. But you'll just need to bring in the .shps. It's going to be tricky for me to find any particular location on these. So yeah, we can see that these are essentially shapes. There'll be instructions in terms of the coordinates of each of these points around the outside, and then it basically just draws lines in between. If we bring in the other type of layer, the raster layer, something weird will happen when I bring these in. There'll be an odd pop-up, and I'm trying to figure out exactly why it's happening, because it's only something that's happening recently, and it doesn't quite recognize the coordinate reference system. that these files are using. So I'm just going to cancel these and manually change, go away, manually change the reference system to National Grid. I'm going to zoom to layer so you can see like the buildings here. If we look at these buildings, so the image files are displayed above the vectors at the moment, so I'll just drop these down below and then we'll get the vectors drawing on top of them. So you can see here with these, with the vector layer, you can zoom in as far as you want to go. We're actually at 1:1 scale there, so this is true to life size, and there's no change in how crisp that line is because it's drawing it every time we change the scale. With the vector maps, that same building looks okay at a certain scale, but as you zoom in, it then gets blocky. And that's the individual kind of unit on a raster map. It is just a pixel of a certain color, where put the vector back over the top of that, and it's this clean, crisp, accurate line. So that's the kind of pre-georeferenced files that you can get either for free or to purchase. Let me find where the site is that we're working on. I think it's down here. That's our park there. It's Fog Lane Park in South Manchester. So say we have some files that have not been georeferenced. These may have been provided by the client, or you may have got them from some other source. Just as an example, I am going to just take a screen print from here and use this as an ungeoreferenced map. So this is our project here, base maps. So that's it here. It's basically just an image file. If we, let me get rid of this PowerPoint. If we take that image and literally drag and drop it, it'll first ask what coordinate reference system you want to be using, British National Grid, and then it will appear in a default location, which is at 0, 0 on the British National Grid. So if we zoom to that layer, you can see that it's not where we want it to be. If we look at the top corner here, if we look at the coordinates here, it's at, let me get exactly right. Ooh. Anyway, the top corner of here is at 0, 0. So that's basically off the southwest coast of Devon and Cornwall. So not in the right place. It's not in South Manchester. So we can't just do it like that. It needs to know where to position it correctly. So I'm going to remove that layer. We're going to be using the georeferencer tool, which I believe is actually a plugin, and it isn't loaded already. It should appear on the raster toolbar. If it doesn't appear there, you need to go to plugins and manage and install plugins, and then it's this one here. So if you type in georeferencer, it'll come up, georeferencer GDAL. If you click on the install plugin, if it isn't installed already, and then you tick the box to have it displaying as well. I can't remember honestly if it's installed already as part of the core package. I can remember in the past that I've had to install it, but going from different versions of QGIS, it kind of saves some of your settings, and I can't figure out exactly where, so I can't make this look like a complete fresh install like everyone else will be using. But anyway, click on georeferencer. We click on open raster. We find our map. Oh, screen pring, can't type apparently. We give it our coordinate reference system, and now we have that here. So the whole point of what we're doing here is adding control points. These are the options here: add control point, delete, or move. And a control point is basically we add a point and then we give it coordinates for that particular location. Or if we have a map that's already been georeferenced, we can line those points up together. So if we zoom back to these layers, our park is down here. So there's two options here. You can see here, obviously we've got, oh sorry, accidentally clicked there. We've got common locations here. This corner where we meet up with the road, or say this building here. These are common points on both maps. So what you can do is not either. First point is left click, create new point, and then it'll give you this option. Either input the X and Y coordinates, remembering that these are British National Grid, or you can click here from map canvas. So if we were going to input the coordinates, we would need to know what exactly they are. If we go back to where we got this map from, you've got a coordinate readout down the bottom here of the X and Y coordinates, of the numerical grid, British National Grid coordinates, and also the alpha numerical coordinates as well. So if we go up to this top corner here and hover over our chosen point, which is here, we can see now in the bottom corner that'll give us the grid reference. What we do with that then is go back into here and type these in. I'm just going to, the other option, click from map canvas and click here and click OK. So that gives us our first point. I've got it so it pops up with this yellow box showing the actual grid reference. You can add and make adjustments to that in here. You can turn them on and off, show IDs and show coordinates if you want to. That's just a personal preference. So another common point would be maybe in the road here, corner. you basically want to kind of have sort of like 4 corners worth of points. So point here. Again, you can either, if you've got a base map already loaded in, that's been pre-georeferenced, then you can just click on the common points. If you haven't, then you'd have to get the XY coordinates to actually input those. And then we'll take a final point. I'm eyeing up the corner of this woodland here. That's common on both of these. Click OK, we can zoom out. So we've got a good spread of points. They're not all kind of clustered in one location, they're spread out kind of across the 4 corners of the map. We then need to tell it what settings we're going to use to actually georeference this, how to transform it. I'm not going to go into the differences of why we choose these different options. I'm just giving you options that work well in most situations. So choose helmet, nearest neighbour. We're working in British National Grid, so it's British National Grid. You will get a default file created in the same location as where your original image file was, or you can click on the 3 dots and change the location of that. I'm just going to leave it here. If your map is going to be rotated, if your original map isn't north facing, you may want to choose the option of use 0 for transparency, because when it rotates you'll get this horrible black background in the original footprint of the map. Using that will turn it off, but it'll also wash out some parts of the map. The other option we've got down here is loading QGIS when done. Click OK. That won't start the georeferencing process. You have to then click this button here, which is Start Georeferencing. If you press Start Georeferencing without going into the settings, transformation settings, it will prompt you to open that up. Sorry, don't want another point, but if we press play now, that's now into our map. If we just minimize this, and we'll check how accurate this is. There's a couple of ways you can do that. You can either make this more transparent. So we'll drop the transparency down there. So that, sorry, I should explain that. If we go into properties, then transparency, and then drop that slider down and press apply. And then you can basically see has that overlaid with the layer below it. And we can see that's about right in the right location. If you've got a vector map as well, you could turn some of those points on, so we can see that building is kind of roughly in the right location. Those ponds, the outline, also kind of nearly match up with it as well. I've done this fairly quickly, so it's a little bit off, it's not perfect. But yeah, once we've done that, we can close the georeferencer window, and then that will prompt you to ask if you want to save the ground control points. Click save, and then that's now fixed. So if we go into our project folder, we can see now we've got our original, we've got our ground control points saved, and we've also got a new modified map that is now georeferenced. So if we dragged and dropped that into the project, if we remove this, then it would basically just drop it back in the correct location without having to go through that same process again. So another type of data that we may have to deal with and bring into the project, again, I'll just borrow that from Magic. I'm hoping that most people are familiar with this website. It's DEFRA.gov website called Magic Maps. We can also get aerial photography from here as well. So we can follow exactly the same process with this. So we'll snip the data. There are other ways of getting aerial photography into your project, but this is the only way I'm going to show you for the basic course. You can do things like add plugins and add web-based layers where you can bring in sort of like Google Earth imagery and other sources, but I'm just using this as an example on how to georeference, so we'll not go into that today. There are some complications when you're working with British National Grid coordinates and also then overlaying something like Google Earth images, because they work on two different coordinate reference systems, and you need to make sure that they're projecting correctly between the two. So again, not going to go into that today, but at least this is one method of allowing you to get aerial photos in. I'm just going to call that photo. Ooh. Partly because I always spell aerial wrong. So again, same process, open georeferencer, got the photo layer, going to call it British National Grid. Like I said before, this also works for PDFs. You can open a PDF through the georeferencer window, but a lot of the time georeferencer doesn't like PDFs if they're large and complex. It's better off if you convert that PDF into an image file, not by screen print, but actually using sort of like there's a lot of free websites that will convert a PDF into an image for you, or if you've got access to something, some of the Adobe tools, some of the Adobe programs will convert over for you as well. But it's usually best to work on an image rather than a PDF. But PDFs can work. But what I've found is if you've got a large site and it's a large complicated PDF, you will occasionally get slowdowns and crashes of QGIS. So best to work with imaging. So again, with this, you've got two options. You can either find common points, or you can find actual coordinates. With things like maps, you're not always going to get common points as crisp as you would with a ordnance survey base map. Sometimes it's because of the angle of the image. So with a building, sometimes it's unclear if it's the edge of the roof, or if it's the edge of the actual footprint of the building, and that can kind of give you inaccuracies. Or where you've got a boundary, it may be covered with trees. Trees are actually a good way of georeferencing things, because it's usually a nice little kind of discrete point that you can find common on your map and also your original source. Say here. Let's go through using coordinates actually. So let's find some good common points. We've got some kind of white object here. So the tricky thing is now, as soon as I move my mouse off here, the coordinates in the bottom right corner are going to disappear. So I'm going to take a print screen. Come into this map. It was this white object here. Now I need to open Paint to get that map pasted. So we've got our coordinates down in the bottom here. So this is a usually I'm working on two screens, so it's not usually this fiddly. Right, so oh, this is going to be a pain to do. 385,228. 385,228. 392,030. Hold on, was that right? 392. Fly. So then you've got your common points. Football pitch could be useful. Could pick out like the center point or a corner. Actually, what I'm going to do is make this only half screen, so then I can have it on the other side of the screen. Here's the georeference a bit down the bottom corner. So, and then get my map from Magic up on the other side of the screen. Right, common points. Oh God. Oh, copyright's in the way. I'm going to go for a little. This is the wear caused by the goalkeeper. Obviously, it's not zooming on here as it is on the Magic site because we've taken a screenshot. Where on Magic, it's showing a different level of zoom each time we actually zoom in. So if we hover over here, I'm hoping that I'll hover over here, that'll update, and then I can just start typing. Yeah, 385, 553, 391, 870. And then we need 2 more points. I think I'll probably use one of the cars down here. White car's sticking out the most, so click on here. The windscreen of the white car. Probably, actually it's a white van. Canvas, so this is a real pain when you don't have 2 screens. You could write it down on a piece of paper. And one final point from this side of the site. Maybe we'll just use one of these trees. I did say that trees were useful for getting georeferencing points. Or even where these paths intersect. We'll use the path intersection. Oops, 385146. Sorry guys, this bit is a little bit dull, but at least it shows you the full process. Both different ways of doing it. So click OK. So again we have these 4 control points. Usually the more control points, the more accurate control points, the more accurate your georeferences are going to be. If you've got an image that is warped in any way, that isn't quite right, there are other transformation settings you can use to have kind of local warping in the map, so you can put more points in a particular location, so it'll kind of stretch those local points out, where generally this way of doing it, helmet nearest neighbour, that just kind of stretches the whole canvas out in an even kind of way. Because we're taking this from somewhere we know that is displaying this in the correct British National Grid format, we know that when we overlay this onto our map, it only needs to be stretched and repositioned in a even way. Anyway, let's press play. Let's just double check that by, again, we can have the buildings overlaid on top, so they kind of match up with buildings. We can stick other things like roads on, and surface water and woodland, and they do overlay quite nicely in those locations. So that's base. Well, let's finish this off properly. We need to close the georeferencer window and save the control points. So we should go a little bit into the anatomy of a project at this point and look at all the files that are being created as a result of saving this project so far. So an actual project file, that's what's created. It's just the QGIS file. In the base maps, we brought in the photo and we brought in the screen pring, and that's then created point files for both of those, and then created a modified version, which is like a georeference version of them. And that's what we have so far. So at this point, we will. So basically, you can completely delete this project at this point. So you could delete this file, and it wouldn't affect these files. So a project file holds all of the formatting information for all the layers that you're including in a project and the locations of those layers, but it doesn't actually contain the data for those files. So it doesn't contain the image for the images, or later when we come to creating features in a shape file, it won't contain these individual files. These are separate files. You load them into a project. The project remembers where these are and contains information about how to format these, but the actual shape files themselves and all the data on how to draw those shapes are contained within these files here. So each one of these shape files will go by name, so then it'll group them. You can see there's 4 different files here. Sometimes you get more than that, but it is a grouping of files for each of these layers that we've got over here, rather than just a single file, and the data is held within these files rather than the project file. I hope that's clear. And I think that is now time to move on to our next lesson.